Welcome to my channel. In this video, we will explore what a provider is and how to use it in a Flutter application. We will write a simple app using clean architecture and provider as a service. I should mention in advance that if you're not familiar with Flutter, it would be best to check out my playlist on the channel for learning it. Let's first discuss what a provider is. Provider is one of the most popular ways to manage state in Flutter. In simple terms, provider allows you to supply data and manage the state of your app in an easy and convenient way. It saves us from the need to pass data through multiple layers of widgets and allows us to update the UI when the data changes. When using provider, you create a data provider, and then listeners, such as widgets, subscribe to changes in that data. When the data changes, all subscribers are notified and automatically updated. Without using packages like provider, passing data in Flutter can become quite complex. Imagine we have data that needs to be passed from the root widget to several nested widgets. Without provider, we would have to explicitly pass this data through each level. This is known as prop drilling. Provider solves this problem in the following way. First, we create a provider that holds the data and methods for managing it. This provider becomes available to the entire subtree of widgets. Any widget in this subtree can access the provider and subscribe to data changes. Now, let's look at the main types of providers available in Flutter. But before that, let's import this package. We will use some of them in our project, so it's important to understand how they differ. First, there's provider. This is the basic type of provider used to supply simple objects. For example, you can use it to provide a configuration object or a service that does not change. Here's how you create it. It takes a parameter of type create, where we can pass an anonymous function. This function has one parameter of type context and must return a value that we want in our provider. In this case, we simply return an integer, so our provider will be of type int. Next is change notifier provider. This is the most commonly used provider. It works with the change notifier class, which allows notifying listeners about data changes. Let's try creating it and passing a number. As we can see, this leads to an error because we need to create a provider with a value that inherits from the change notifier class. For example, we can create a class that simulates a state. It will inherit from change notifier using with. It will hold a variable that is initialized to 0 by default. We'll also write a method that increases our variable by 1. After that, we call notify listeners, so that any widget subscribed to this provider will receive updates. Now, let's pass an instance of this class to our anonymous function. As we can see, this time there are no errors. Next, we have future provider. This is used for asynchronous operations, such as API requests. It allows you to provide the result of an asynchronous operation as data for subscribers. It requires an initial data parameter, which we can set to null. In the anonymous function, we must return an object of type future. For example, let's write a simple future function that will return a string after a few seconds. We will call this function in our anonymous function and return its result. The next type is stream provider. This is used for working with streams of data such as stream or WebSocket. It provides data that changes over time. It also requires an initial data parameter. Now, let's determine the create parameter. For example, let's create a method that returns a stream. Notice that we mark it as async asterisk. We'll return numbers in a loop using the yield keyword. This creates a stream that adds data 10 times. We'll return this in the anonymous function of the create parameter. These are the main types of providers in Flutter. To access them in our app, we need to wrap them in this widget. For example, let's do this with a basic provider by passing our app as the child. Then, inside our widgets, using the context, we will call the read method. Notice that we need to specify the generic type for the provider we need. For example, in this case we need a provider of type int because it returns a simple number. After that, we can use this variable in our widgets. Now that we have a general understanding of what a provider is, let's start building an app using provider. We will use clean architecture. Let's get started. We'll write a to-do list app while following the principles of proper development. First, let's create 2 folders, Core and Features. Inside the Core folder, we'll create a model folder, where we'll define the models used throughout the project. Let's start with the either model. The either model is one of the functional programming patterns used to handle results that can be either successful or erroneous. It is an alternative to exceptions and is commonly used in clean architecture to make the code more readable and reliable. Let's see how this works. First, we declare an abstract class that takes 2 generics. This class will have a fold method, which is also generic. This method takes 2 functions for each type of value. Next, we create 2 classes that inherit from it. Let's start with the left class. It must take the same generics as the parent class. However, unlike the parent class, it will have a value of the left generic type. We will override the fold method and call the function for the left value, passing our field to it. We do the same for the right class, but this time we use the right generic type and call the right function. This is the idea. We'll use this either class as the type for functions that can either succeed, returning a value, or fail with an error. In the case of success, it will return right, and in the case of failure, it will return left. When calling it, we'll use fold to handle both cases. Don't worry if you didn't get the concept right away. You'll understand it soon. Now, let's create a failure class. This will be an abstract class with a single string field for displaying the error. Then, we'll create another class that will inherit from it, representing a failure when working with a database. Next, let's move to the Features folder. The essence of clean architecture is to divide the app functionality into features. Since we will display tasks, let's name the feature task. So we need to divide this feature into 3 parts. The first part is domain. Here we'll implement business logic, or the app logic itself, without any specific implementation. The next part is data. This will contain the concrete implementation of our business logic, such as fetching data from a database. Finally, we have the presentation part, where we'll implement the UI and providers. I usually start with domain, specifically by creating an entity folder. Here we'll create objects representing the key business entities in the app and describing their properties and behavior. In clean architecture, an entity is a pure business model, independent of any specific implementation or framework used at the domain level and containing only the fields necessary for business logic. For example, in this case we'll create an entity for task. It will have fields like int ID, title, description, is completed, and created at. Notice that the ID field is nullable. The title and description fields are string, as they store text. The is completed field is bool because it stores either true or false. The created at field is of type datetime, which stores both the date and time. Don't forget to add the constructor. Next, let's create a folder for repositories and the repository itself. In this case, it will be a repository for working with tasks. This will be an abstract class that doesn't contain implementation, but only describes business logic, as we are at the domain level. We'll declare a method to get all tasks, which will return a future because it takes time. We will use our either type. Since we know the operation will either succeed, returning a list of tasks, or fail, we'll make the left generic our failure class and the right generic a list. Thus, we'll have a type that will return either an error or a list of tasks. Next, we'll declare a method to get a task by ID. Notice that this time the right generic of our either is not a list but simply a task. The method will also take one parameter, ID. Finally, we declare a method for creating a task. In this case, the right generic will be void, meaning it returns nothing if the operation is successful. It will also take a task entity as a parameter, which we want to add. The next method is for updating a task in the database. It will be of the same type as the method for creating a task. The last method is for deletion. Unlike the previous method, it will take the task ID that we want to delete. Now, after creating the repository, we will create a folder for use cases. A use case is a class that describes a specific business operation performed in the application. It contains the logic related to that operation and is used to separate business logic from implementation details. Using a use case makes the code more readable, modular, and easier to test. For example, we will have a use case for creating a task, which will describe only this operation. At first glance, it may seem unnecessary, and you could call the methods directly through the repository, but in large projects, this significantly simplifies testing and overall code readability. Now, we need to create a use case for each business operation. Let's start with fetching all tasks. This class will have our abstract repository, which describes the methods. We will also have a call method that will be of the same type as our business operation. Inside this method, we will simply return the result from the repository method call, without forgetting about await. As you remember from our Flutter playlist, if you've watched it, when we call the call method, we can invoke it without an explicit name. For example, here's how it will look. This is not mandatory, but it does improve code readability. Now, we need to continue like this for each operation. Thus, we have implemented the domain layer. Note that we have described the entire business logic of the application without making a concrete implementation. Now, let's move to the data layer. Here, we will implement the logic for working with business logic and specific data sources, such as a local database. Let's start with the model folder. Here, we will create models that, at first glance, look very similar to entities. But a model is a class representing data used to store and transfer between different layers of the application, such as fetching data from an API or a database. Unlike an entity, which only describes business logic, a model may contain additional methods for transforming data, depending on the specific implementation or data source. We need a model for a task. Here, we will inherit from our entity. Now, we need to implement methods to transform our object into a database format and vice versa. This will be a map with string as keys and dynamic as values. Here, we will simply return a map where each key corresponds to a value. However, our Boolean value will be converted into an integer. This is necessary because we will store data in a local SQFlite database, which does not support bool. If our field is true, we will return 1, otherwise 0. We will also convert our date into a string, as our local database does not support the datetime type. We will convert it using the Todo 8601 string method. Now, let's write a factory constructor for converting from map to our object. Note that we account for the fact that we converted the Boolean into an integer. Therefore, we will simply assign the result of equality to 1. We also need to convert our date, which we turned into a string, back into datetime. For this, the datetime class has a factory constructor parse. We will pass our string to it. In addition to this, we need to create a factory constructor that will convert our entity into a model. Since our model inherits from the entity, converting it to an entity will not be a problem. But for converting back, we need to write a constructor for it. It will work simply by creating a new model based on the fields from the entity. Now that we've created the model, let's create our folder for data sources. A data source is a layer in the application responsible for fetching data from different sources, such as a local database, API, or file system. In clean architecture, the data source is used in the data layer and where the data comes from without including the business logic. It's just an interface for interacting with external data sources. We will use SQFlite, so let's import this package as well as the path package, which we need to get the directory we need. By the way, we can import dependencies without specifying a version. After importing, let's create a database folder in the core and create a file to work with the database. Here, we will implement the creation of the database as well as the ability to retrieve it. To do this, we create a static getter of type future. We will return the result of the Open Database method. This method is provided by the SQFlite library. We pass the path as the first parameter. We will do this using the join method from the path library, which joins two paths. The first path comes from the getDatabases path method from the same path library. We also pass the name of the database itself. It must have the extension DB. We also need to pass the version parameter. Let it be 1. Then we pass the onCreate parameter, which accepts a function. This function will be called to create the database. It has two parameters. The first parameter is of type database, and the second parameter is of type int, which is responsible for the version. To create the database, we should use our first parameter of type database and call the execute method. Here is how it looks. We give our table a name. Then we list the fields and specify their types. The first type, ID, will be marked as primary key auto increment, as it will be a mandatory identifier that automatically increments itself. And then we list the other fields. Don't forget about await keyword. Thus, we have implemented the ability to create and get the database. Now, let's create a class for the DataSource to work with the local database. It will accept a database that we will get from our database class in the future. It will contain methods to work with this database. Let's start with the method for fetching all tasks. Note that here we do not use the either type, as this is the innermost layer working with the database and it's not needed here. To fetch the list, we will use the query method, passing the table name. This method will return all elements as a list of maps. We need to convert this list of maps into a list of task model. We've already covered how to do this, so we won't linger on this. Next, we create a method for creating a task. It will be of type future and accept our model as a parameter. For insertion, we will use the insert method, passing the table name as well as the task converted into a map using the method we wrote in the model. The next method is for updating a task, which is similar to creating. But for updating, we use the update method. We pass the table name and the map from the model. In addition, we pass the where and whereargs parameters. The logic here is that we want to update the object where the ID is equal to the one we pass in whereargs. The syntax may seem confusing, but you just need to remember it. Then, there is a method for deleting from the database. Here, we use the delete method, passing the familiar parameters. It's simple. We delete the object where ID matches the one we pass. The last method is to get a single task by its ID. The logic here is the same as when fetching all tasks, but we also pass additional where and whereargs parameters. The result will return the first element converted through fromJSON. Thus, we've written a local data source for our tasks. The final touch in the data layer is that we need to implement the repository from the domain layer, linking it with our data source. It will inherit from our interface and implement its methods. It will also have our local tasks data source as a field. The logic is as follows. We will call the methods inside a try-catch block and return right. Note that where we need to pass a model, we use the factory constructor to convert the entity into a model. The thing is that the methods accept entities because they are described in the domain layer, but the local data source requires models, not entities. However, when we try to return the model as an entity, there's no problem because, by inheritance laws, any model is an entity, but not every entity is a model. If there is an exception, we will return left, passing an instance of our failure with the error message. Thus, we need to implement all the methods using the local data source. Now, let's move to the presentation layer. We will use Provider as a state management tool. Let's start with the Tasks Provider class, which will inherit from Change Notifier via with. This is necessary because it will be a Change Notifier provider. This allows us to change the state and subscribe to changes through widgets. First, we create fields for the use cases. Don't forget to add them to the constructor. We also need to add a field for the status. For this, we create an enum and use this type in our provider. Now, create a field for an error message if there is one. By default, it will be empty. Also, create a field for the list of tasks, which we will get through our use case. Now, let's move to the methods. Let's start with the method for fetching tasks. In this method, we will first set the status to loading. After that, we call notify listeners. This is needed so that all listeners of this provider receive the updated state, including the status variable. Next, we call our use case. As a result, we get an either value. To handle it, we use the fold method. In this method, we pass two functions. The first function handles the left value, and the second handles the right value. In the case of the left value, we set the status, error message, and reset the task list. After that, we call notify listeners so that listeners are updated with the changes. In the case of the right value, we set the status to the desired one, clear the error message, and update the list with the tasks from the parameter. Again, don't forget to call notify listeners. We do the same for the other methods. Notice that in the method for adding a task, we call the method to fetch all tasks again after successfully adding a new one. This is necessary so that we get an updated list with the new task. We do the same when updating or deleting a task. We have now created a general provider for retrieving and displaying the task list. Now, let's create a provider for fetching a single task by ID, which will be used when a task is clicked and the details screen is opened. Of course, in this case, it doesn't make much sense, as we can simply pass the task instance. But in large projects, when the client fetches a list of objects, they are usually not fully detailed and contain only the most important fields. If the client wants more detailed information, a request to fetch by a specific ID is used. Therefore, to simulate this, we create a new provider. We'll also create an enum for its statuses. Keep in mind that each provider has its own enum with statuses, as each provider can have different statuses. In this case, we will only have one use case. The fields are the same as in the previous provider, but instead of a list of tasks, we will use a single task. Similarly to the previous methods, we create a method for fetching a task by ID. Thus, we have implemented the providers, and now we only need to implement the screens. We won't focus too much on the UI, since one of the advantages of clean architecture is that the user interface is independent of the business logic implementation. This means you can use any approach for the UI. Additionally, if we focus on creating a unique UI, it will take a lot of time. I suggest you create your own UI as a practice, while keeping the business logic of the app intact. Before that, we'll implement Dependency Injection, DI. For this, we import the get_it package. Dependency Injection is a design pattern that allows passing dependencies from the outside, rather than creating them internally. This makes the code more flexible, testable, and reduces coupling, as the class doesn't depend on concrete implementations, but only on interfaces or abstractions. You'll understand everything now. Inside the core folder, we create a new folder for DI, then create a new file called GetIt. In this file, we declare a global variable, so we can access it from anywhere and assign it the following value. Now, we write methods to register our objects with it. Let's start with the database we created. For this, we use the register singleton method of get_it. In this method, we pass the object we want to register. In this case, it will be the getter, marked with a weight. This way, we've registered a database object. If we need it anywhere in the code, we can simply call GetIt.call, passing the required generic, and it will provide the object we registered. Moreover, we don't need to explicitly use the call name. Next, we need to register all the data sources. In this case, we have only one. Note that it requires a database, and instead of creating it, we simply get it via GetIt, since we've already registered it. We'll do this for all dependencies in our app. Now, let's register the repositories. Notice that we pass the implementation of our interface, but we specify the interface itself in the generic. This is important because when we request an object of our interface type, we get its concrete implementation. This is the advantage of clean architecture. If we decide to change the implementation of our interface, we simply create a new class that implements the interface and pass it here. Nothing will break because the UI depends only on the interface, not on its implementation. Next, let's register our use cases. After that, we need to register our providers. Now, we need to write a method that will call all the other methods in order. This method will be called in our main file before running the app. Now, let's begin implementing the UI. Let's start with the home page. It's simple, we will use a scaffold. Inside the scaffold, we will use a list view. But now we need to make sure that this list view fetches data from our provider. To do this, there's a widget called Consumer. This widget will get data from our provider and display it. It will update the display every time the data changes. Let's look at this in practice. First, we pass the generic of the type we need for our provider. In this case, we need the provider that holds all the tasks. Then we pass the builder parameter. We need to pass a function that will return a widget. It has 3 parameters. The first parameter is the context, the second is the provider from which we will get the data, and the third is the widget. In this case, it's optional and is used only when we pass a child parameter to the consumer. This is the part of the UI that doesn't change based on the state. In the builder, we will check the status. If the status is loading, we return a loading indicator in the center. If we have an error, we return the error message in the center. Notice that we access all fields through the parameters from the function. If the status is successful, we return the list view with the tasks. We won't go into more detail here because there's a video tutorial on this topic on my channel. We will display all tasks from our provider. Let's also create a separate widget to display each task. It will be a stateless widget that accepts our entity. We will have a checkbox in the widget that will take its value from the entity. We also need to implement the ability to mark the task as completed and vice versa. For this, we use the onChanged parameter, which has one bool parameter indicating whether the checkbox is checked or not. Here, we need to call the method to update the task from our provider. To access our provider, we use the context and call read. We pass the required generic type for the provider. After that, we can call the needed method. We should pass the task entity but with the opposite value for is completed. For such an operation, it would be useful to create a copy with method for our entity. This method will return an object of the same type but with modified parameters if they are provided. Here's what it looks like. The logic is simple. If we pass a parameter, it is used in the new object. If we don't pass a parameter, it will be null, so the value from the current instance will be used instead. Once we have this method, we can use it to update the isCompleted field. If the user checks the checkbox, the parameter will be true, and the object will be updated with isCompleted =true. This widget will be used in our list view. In other cases, we will return empty widget. We also need to add tasks. To do this, we will use a dialog. We'll write a floating action button for our scaffold. For the dialog, we will create a separate file. It will have two text field widgets for the title and description. We have already covered how to implement such dialogues in our playlist, so we won't go into more detail here. When the Create button is pressed, we will call the method for creating a task from the provider. We access the context and use read. We will create a task, passing in the data from the text field widgets, the current date, and is completed =, false by default. We will open this dialog when clicking on the floating action button. Next, let's write the page that will open when clicking on a task element in the list view. It will accept the task ID and display its information. The logic is as follows. It will get the task entity by ID and display its information. We do this similarly to the previous page, but this time we pass a different generic to the consumer. We check statuses, and in the case of a successful status, we return the task details. Since this is just an example, we won't focus on design or date formatting. In other cases, we will return empty widget. After creating this page, we will navigate to it when clicking on a task in the list view. Don't forget to pass the task ID. Now, it's time to create our providers, so we can access them via context in the app. The provider for all tasks will be created once for the entire app, meaning it will persist from the start to the end of the app's lifecycle. However, the provider for fetching task details will be created every time we navigate to the Details screen. When we leave the screen, it will be disposed of. This is necessary because we want access to all tasks throughout the app, but we only need access to a single task on the Details screen. For this, on this screen, we wrap our widgets with a Change Notifier provider. We need to pass a Create function. This function will return the provider we want to provide. It accepts the context as a parameter. Since we've already registered our provider in GetIt, we will use it to get the instance of the provider. Now, we need to provide a provider for all tasks. We will do this in the main file. First, we will write the code to start the app and make sure to pass the main page. Then, we will wrap our material app in a change notifier provider. As before, we will use GetIt, but this time with a different generic. Additionally, I want to make sure that when the app starts, a request to fetch all tasks from the database is automatically made. For this, I will use the cascade operator to call the appropriate method. The same thing will be done for the other provider, but for this one, we will make sure that when it's created, the task is fetched by its ID automatically. Now, we need to call a method to register all dependencies in GetIt. But before that, we need to call the following method. Now, let's test the app. However, we see an error. The issue is that we forgot to add a parenthesis in the command for creating the database. Let's fix it and run our code again. As you can see, everything works. Tasks are added, we can change their status, and we can navigate to see the details. For homework, I suggest you try implementing the task deletion feature. We already have a method for this in the provider. That's all for now. Together, we built a simple Flutter app that follows the principles of clean architecture and uses provider for state management. If this video was helpful, please make sure to like it and subscribe to the channel. If you have any questions, feel free to leave them in the comments, and I will try to answer them. Good luck, and see you in the next videos.